Okay, question A3, T61, A01. This question says a technician finds the following conditions. So, number one, air entering a chilled water coil is 75 degrees dry bulb and 50% relative humidity. Well, we know what's happening when air enters a chilled water coil. It's going to cool and its characteristics will change. And so eventually we're going to be looking very closely at this psychrometric chart in order to analyze how its conditions change. But specifically in the question, let's take it from the top again. We enter a chilled water coil at 75 degrees dry bulb, 50% relative humidity, and it leaves the coil, let's underline that, leaves the coil at 55 degrees dry bulb. So we've actually cooled the air immensely by 20 degrees of sensible heat, sensible reduction in temperature. So we've cooled it from 75 to 55 by moving it across our chilled water coil. And our relative humidity goes way up to 95% relative humidity. And the change in the air enthalpy is 5.4 BTUs per pound. What does that mean? It means every pound of air that moves through that chilled water coil will give up 5.4 BTUs of heat energy to the chilled water flowing through the coil. Now we know some extra information. We are giving dimensions of the supply air duct. Supply duct size is 6 feet by 4 feet. We know the velocity pressure through the duct is 0.03 inches water column. And we know some conditions about the water on the chilled water coil. So we've got chilled water entering a coil at 45 degrees Fahrenheit. That's a nice temperature for chilled water off a chiller system. And it's going to leave the coil at 55 degrees Fahrenheit. So we have a series of questions based on these conditions of air moving across a chilled water coil. Let's think big picture. We know that the air is going to leave cooler with its conditions changed. We know that the water is going to leave the coil a little bit warmer, and its conditions have changed because, of course, heat transfer happens from the air to the water. And question number one says, what is the velocity of the air flowing through the ductwork? That's question number one. Okay, so to solve the first question regarding the characteristics of air flowing through our chilled water coil, we need one simple equation that is going to come from, our reference manual. And that equation I'm going to draw right here. It's that the velocity of the air, this is measured in feet per minute, is equal to a constant number of 4,005, right, times the square root of the velocity pressure. So we know the velocity pressure. We're given that in the question. And we know 4,005. So this is a very simple calculation. Let's bring it down here. We're going to have 4,005 times the square root of 0.03 inches of water column. Okay. And as it turns out, that equals 693.7 feet per minute. So we didn't even need to interpret information from the psychrometric chart in order to answer question number one. Let's toggle over and make sure that we know the next answer is correct. And it is indeed 693.7 feet per minute.